This slide shows the overview of my talk, and first I'd like to role of calcium-activated chloride channel in cancer cells and epigenetic modification of gene expression. And so various types ion channels, so potassium channel and the sodium channel and the chloride channel and the calcium channel is responsible for the regulation of the cell function, such as neurotransmission and muscle contraction and cell proliferation and apoptosis and migration and invasion. So ion channels also contribute to various cancer processes by the regulation of the resting membrane potential and intracellular calcium signaling directly or indirectly. And pharmacological inhibition of ion channels is an attractive target to prevent cancer cell proliferation and metastasis. And so our target, calcium-activated chloride channel, TMEM6A, has 8 transmembrane domains and is located on the chromosome 11q13 that is frequently amplified in the various cancer cells. And overexpression of 16A chloride channel modulates the various types of intracellular signal molecules and induce the proliferation and migration. And so in the breast cancer cells, so overexpression of 16A chloride channel is observed and reported that. So 16A chloride channel is an attractive therapeutic target and a novel biomarker for breast cancer. So the balance of histone methylation and histone acetylation is important in the regulation of the gene expression. And so in tumor cells, oncogene is on and tumor suppressor gene is off. And then application of the histone deacetylase inhibitor, so HDAC inhibitor, induce the off of oncogene and the on of tumor suppressor cells, so resulting in the cell cancer death. So epigenetic modification therapy with HDAC inhibitors is one of the novel strategies for cancer treatment. So we found the downregulation of 16A chloride channel by HDAC inhibitor vorinostat in human breast cancer cells. So vorinostat is approved for the treatment of T-cell lymphoma and is developed for the other solid tumors, including breast cancer with combination drug therapy. So A showed the gene profiling, so gene expression of the 16A chloride channel in human breast cancer cell lines, such as YMB1, MDA, MB453, MCF7, and so on. So 16A chloride channel highly expressed in the HER2 positive cell lines, YMB1 and 453 cells. And in YMB1, we did the patch clamp assay, and so this is 16A chloride channel activity is observed with typical electrophysiological profiles. And so application of the 16A chloride channel inhibitor nifuramic acid induced a decrease in the cell viability. So we examined the effect of the vorinostat on the cell viability and the 16A chloride channel expressions. So first, we examined the cell viability experiment and the vorinostat. So treatment with vorinostat for 2 days induced a decrease in the cell viability in a concentration-dependent manner, and 16A chloride channel expression is suppressed by the treatment with the vorinostat, So this is mRNA level and the protein level. And also we did immunocytochemical assays. So expression of the 16A clear channel along the cell membrane is decreased by the treatment with the vorinostat. So next, so we examine the effect of the treatment or vorinostat about 30 hours on the calcium-activated chloride current. So chloride activity is markedly decreased by the treatment with vorinostat. She showed the summarized data of current and voltage relationship. Treatment with the vorinostat induced a marked decrease, so significant decrease in the calcium-activated chloride current activity. So next, to determine the HDAC subtype related to the downregulation of the 16A chloride channel, we examine the effect of pharmacological and siRNA-based blockade of HDAC subtypes on 16A chloride channel transcription. So of 11 HDAC subtypes, HDAC 1, 2, 3, and 6 are highly expressed in YMB1 cells, inconsistent with the expression patterns in human tumor breast tissues. So we use 3 different chemical compounds. So AATB is selective for HDAC1 at a lower concentration, and is also selective for HDAC2 at higher concentration. And T247 is selective for HDAC3, and the NCT compound is selective for HDAC6. So the pharmacological blockade of HDAC3 by T247 induced a large decrease in the 16A expressions. And pharmacological blockade of the HDAC2 by higher concentration of AATB induced a partial inhibition of the 16A chloride channel expression. And so pharmacological blockade of HDAC1 and HDAC6 did not induce any significant changes in the expressions. And also chemotherapy drug paclitaxel did not induce any changes in the expressions. So we confirmed the HDAC subtype related to the downregulation of the T-MEN 16A chloride channel using the siRNA. So as you can see in A, so HDAC3 inhibition by siRNA induced a large decrease in the 16A transcription. And so similar to the previous data, HDAC2 inhibition by siRNA induced a partial decrease in the 16A chloride channel transcription. And so next, so I also performed the electrophysiological assay, and so she showed the marked decrease, so marked suppression of the calcium-activated chloride current by HDAC3 inhibitor T247, and this shows the summarized data. So HDAC3 is a leading candidate for the downregulation of 16A chloride channel in YMB1 cells. So finally, I'd like to talk about our recent work, regulation of HER2 expression by 16A chloride channel. So in the plasma membrane, ion channels and receptors can functionally communicate by forming clusters in lipid microdomains. EGF receptor forms functional complexes with calcium-activated chloride channel and store-operated calcium channels, and contributes to the calcium signaling pathway with them, like this. So EGF receptor make a complex with the calcium-activated chloride channel and store-operated calcium channel. By the lipid raft. And HER2 is an EGF receptor family, as you know, with tyrosine kinase activity, and overexpressed in about 30% of patients with breast cancer, and mainstay of targeted therapy for the treatment of invasive breast cancers. So as I described previously, so 16A chloride channel is highly expressed in the HER2 positive breast cancer cells. So in YMB1 cells, so pharmacological blockade of 16A chloride channel by 801 compound and siRNA-based blockade inhibition of 16A chloride channel induced a significant decrease in the HER2 transcription. And similarly, so HER2 protein expression is downregulated by the inhibition of the 16A chloride channel. So calcium-activated chloride channel is a potential therapeutic target for breast cancer, and the inhibition of 16A chloride channel suppresses proliferation and invasion. So in conclusions, in malignancies with frequent gene amplification of 16A chloride channel, so its dysfunction by HDAC3 inhibition is responsible for the suppressive effects on cell viability in breast cancer cells, and it may be related to the poor invasion capacity observed in metastatic breast cancer cells. And expectedly, so T-MEN's 16A chloride channel induced a downregulation of the HER2 expression. So 16A chloride channel may play an important role in the regulation of HER2 downstream signaling in breast cancer cells. So I acknowledge the collaborators here. So thank you for your attention.